Hello, welcome to our virtual talk. I'm sharing here this presentation with my peers Srijite and Ritika. The title of our presentation is your application all ready? Introduction. So as we build new applications and experiences, we need to ensure that they are developed in a way that can be easily expanded to new regions and languages. So this is probably happening with many of our companies, where the goal is to have more presence in several countries, or at the same time in the same country expand to support more languages, as Arabic, Hebrew, Chinese, French, Spanish. So for that reason, the earlier we can detect bad practices in the development, the better. For that reason, we have built two major plugins that can be used during development and at the same time part of the continuous integration process. These rules, these checks are part of our own playbook. Here, I'm going to show you two examples of what exactly are we trying to prevent. So on the left side, you can see the source. The source is in English. It actually looks perfectly. You have here the text. We say, thanks, your payment was done. And then you have an example, a placeholder, which will be used later for rendering the date. Okay, looks good. But if we go back here on the right side, we see the target is in Spanish, and then you see the text saying, gracias, su pago se realizó el. And then here we have a problem because the date format is showing the month, the day, and the year. And this is wrong because the format that we should be as we have here, which is, gracias, su pago se realizó el 31 de diciembre del 2019. Here we have it correctly, which is the day, the month, and the year. So what happened here? It is possible that maybe a third-party internationalization library, or maybe somebody actually translated. So just look into the source, it looks fine. But when we render the page in Spanish, it looks wrong. So we want to be able to detect this one. This is going to happen for many other languages, but except in the English and maybe in another one. So we want to be able to prevent this. Here is another example of what we want to prevent. We want to be able to catch this even before it goes live. So here, the source, it looks interesting. They haven't externalized the text, fine, great. But then here, when it actually using this one and is rendered in German, we see that the amount is exactly the same as the source. Now, this person that is doing the translation, it is possible not actually be able to handle this. So they just leave it as it is. Now, is this correct or wrong? It's actually wrong because the decimal separator in German is the comma. So displaying this to the end user, it could mean that maybe the user say, oh, there's a typo and it is missing a 0. Oh, wow, it's actually cheap. It's $5. So if it was maybe in euros, maybe it will be a little bit even cheaper. So that's why it could create confusion. So if we see what we should be displaying is like actually the same text, but the amount and the currency should be formatted correctly. Now, I'm not in the business here right now to say that for the exchange, using the exchange rate, but if this is a 101 and we apply the exchange rate, maybe it should be displaying like 4.30 cents, 4 euros. So that's why we want to be able to prevent this even before it goes live. Now, our mission was enforce this detection of poor development practice. That was the mission of doing this. So the question we ask is like, can we provide these tools from day one? Can the developer, out of the box get all this for free? Yes. Can we enforce the good practices since day one? Yes. Can it be there available for the end user, for the developer? Yes, it is possible. This will require configuration and adding this and maybe installing this, or can actually provide a minimal configuration. And the goal is yes, we can, and we were able to do it. Now, it is possible because of some business reasons or because because we are just checking some specific patterns that we have false positives. We don't want to be in the business of just blocking everything. We're actually providing an utility to accept or just to handle the feedback of the false positive. So at the same time, we can provide that. So saying that one, we talk about internationalization, code specific things, and at the same time, we talk about the text, the source, how can we detect bad patterns. So from the perspective of the code, and just to mention that we are just focused on the internationalization. In this case, we are not focusing like a security or other field, for the style best practices, only for the internationalization. So in this case, we are using Eslint, which is an open source, in order to detect what are the type of libraries, if they are using third-party libraries, if they are using maybe hard-coded logic over there, if we want to format a currency or we want to format a date, if they hard-coded those patterns, we are using Eslint for that specifically. Now, from the size of the localization, as the developers, they externalize the content that is going to be displayed to the end user, we are using what we call the localizability scan. So for all this part of the source, the text, we use the localization to detect all those kind of patterns. And if we can actually even not only detect it, but even provide a possible solution that they can do. So in the next slides, my peers will talk about Eslint and the localizability introduction, and at the same time, some of those examples of how to use it.
So our first plugin is Eslint, and the focus is how to detect bad internationalization practices. So on next slide, let's go over the introduction. So it is a JavaScript linting utility, and we are using the this utility to detect bad internationalization coding practices. Next slide, please. So what we mean by bad internationalization coding practices, and here is that, like in first example, we want to detect hard-coded countries, for example, US. So why it is wrong? Because if a feature is enabled or not should be governed by a config. For the basic reason is, let's say we want to enable a similar feature in UK or Mexico. So the developer has to come here and make the code changes, but if it is governed by config file, then no code change is required. The second example here, there's a hard coding of local HE, and on basis of that we are determining whether the CSS should be left to right or right to left. Now let's say if we decide to launch a product in Arabic speaking or Urdu speaking country, then we need to come here and again come here and make changes to the code. In the third example, we see that the content or a text is written between the HTML tags, and this is wrong because as we go and expand to new languages, we need to adapt the content, and also it needs to go for translation. So as we launch in newer market, this could be a big hindrance. In the last example, we see there's a hard-coded currency code, and instead of deciding or formatting on the currency code, this should be governed by a formatting tool, and that's why we need to detect these practices. Next slide, please. So the basic concept of EST and writing rule resides in abstract syntax tree. So whenever we write code, there's a parser. We were using Babel parser, and that forms AST, which is abstract syntax tree. Now let's play the video. So this is an AST Explorer. It has 4 parts. One is like input. This one is how the AST structure, then the code, and finally the output. So wherever you highlight on the left side, it will, on the yellow, you can see that this could be the node structure. And if you dig down, you can see like exactly what node we need to find. Let's say we want to detect US, which is a hard-coded country. So we can see from highlighted portion, okay, it's this part. and we can further drill down to exactly which node is causing it. So in this case, it's a binary expression, and if you go further, it has left and right nodes, and the specifically we are looking for literal, and the value is US. So as per this findings, we write our code in bottom left, and which is like binary expression and whatever the process we want to follow, and on the basis of that, it will start detecting what is the violation. For example, in this you can see the violation detected similarly for Mexico, and but where you see France in FR and GB, there's no violation. So reason behind this, if you change anything in code, the AST structure changes, and here the node type has changed from binary expression to logical expression. So we need to trigger the similar rule for logical expression, and after triggering that, you can see like, okay, this is started reporting. Now, another case is if the country is CA and it's not present in unallowed country, the rule won't be triggered. So takeaway from this is like if you make any change in the code, there's prone that the node structure might change, and these rules are very specific. So we need to think about in like many ways the like developer could write his code. Now we can move to the next slide. So when we write a custom Eslint rule, there are two parts to it. One is plugin, another one is config. Plugin is somewhere all our rules reside, and since in plugin we would be continuously adding more and more rules as per our finding or as per the company standard. So to ease up that process, there is a concept of config, which is on an example is on the right image, where we can control like which rules should be included and what should be the priority. I mean, it should be configured at error level or warning, so that like in the rule there's currently one entry, and you can see there's one and 0 are normally used to determine the severity level, and this is how we can use custom ESP rules. Now moving to the next slide. So there could be many scenarios like where we have detected false positive, or since normally we have tried that these should be triggered as a part of pre-commit hook, and if a rule is an error, this could be a hindrance for immediate release. For that purpose, Eslint has it a way to disable rules. The one way is to disable on a particular line by inline comment, or updating the Eslint config file. This is not a good idea, and we don't advise anyone to use it, because in a way we are kind of not making changes, and like the product won't be world ready. Now moving to next slide. So instead, Eslint has a feature like, instead of waiting till the development, like running your pre-commit hook, it's possible right at that stage where writing the code, it's possible that you are aware of what actually the issue is. So Visual Studio has an extension called Eslint. If installed, it will start giving you like what exactly the issues are, and this is one of the screenshot for that. Now let's move to the next slide. This is a final demo for our Eslint, and let's start with the demo. So here, as you can see, this has all the setup, and there are some issues, and yellow line is the same one which I was telling you about the Eslint plugin. All the configurations are already in place. So at development stage also, like while you are writing the code, the developer is aware about the issues, and since it's running, eventually we will see that, okay, and we will see that it's just that in terminal you just need to write a command which is npm run lint, and it will execute the Eslint rules and give us a report. for example, as you can see here, the rules got executed, and here all everything is currently reported as warning, but as per the convenience we can upgrade from warning to error. And with this, this is what we wanted to show for the Eslint.
So now we will be moving on to the next plugin that we wanted to talk about, which is the localization scan engine. Next slide, please. So this is a JavaScript utility that detects bad practices in all externalized customer-facing messages. So we want to detect these patterns early on to prevent bad user experience when we are expanding to new languages. A few examples of these bad patterns that we try to detect are hard-coded date patterns, hard-coded links, sentence fragmentation, and hard-coded currency symbols. In the next few slides, we will discuss some of these in more detail. So first, let us look at hard-coded date patterns. Now, we try to detect date patterns in content, for example, mm/dd/yyyy. And the problem with having these in content is that when they get translated, the patterns might not sometimes be recognized by standard date formatters. For example, you can see here the pattern we discussed before. In German, it gets translated into tt/mm/jjjj, and this is not a standard date pattern. So a formatter like simple date formatter in your code will throw an error when it receives this. We want to avoid such situations, so it is recommended that these date patterns are removed from the content, and instead the recommended I10n libraries that are used in the company should be used for date formatting. Next slide. Let us take a look at hard-coded phone numbers. Now, we try to detect if there is any hard-coded telephone number in the content. We have this message to call customer service and a phone number that is hard-coded in the content. And we want to avoid these because depending on what type of phone number it is and what location it is from, like USA or Spain, the formatting and the phone number might change, and the translator will not have control of what phone number should be used or what type of formatting should be used for that phone number. So in order to avoid such a situation, we recommend to externalize only the content part of the message and have a placeholder for the actual phone number. Now we also similarly have the same rule, similar rule for hard-coded links. Just like phone number, if the links are part of the content, the translators might not know how to translate or construct a URL when the language or the market changes. And similar to the phone number, we recommend to use only a placeholder for the actual link and just have the rest of the content externalized. Next slide. Now let's look into sentence fragmentation. So here you can see there is the first example is of a fragmented sentence, which is fragmented into 3 keys which have the content, and if you compose a message, there are 2 dates that are also a part of these fragments that come in between these fragments to construct the whole sentence. Now in English, this when you concatenate these fragments, the sentence makes sense, but once you translate it to another language like Japanese, just concatenating fragments, translated fragments in this manner may not make sense in a translated language. So the better way to do it is have the whole message in the content key and have the placeholders for the date, so that the translator has the idea and context of the entire message and can add the translation, placing the placeholders in appropriate places in the sentence. So these were some of the examples that we discussed. Now let us discuss a situation where we want to handle some false positives or exceptions. Now, how do we handle these? We allow the users to add some exemptions to these the localizability scan rules. The app can have a config file in the repo and pass it as an option to the when they run the scan, and this config file just has to have an has to export an exempt function which will basically determine if some content keys have to be exempted from these rules. What are some of the situations in which this may be recommended to use? There can be some generic exceptions, like for sentence fragmentation rule, we do not want to run it in any buttons. Maybe these buttons do not fall under the sentence fragmentation rule. So we have in the first generic exemptions example, we just check if there is the button keyword in the content key, and based on that we determine if it is exempted. In other scenarios, the exemptions can also be very specific to the key. In that case, we can pass the entire path of the content key, including the properties file that it is in. And for example, here there is the first key is legacy key, because, which we want to exempt, and the second one is a false positive, as it is a label, and we can just similarly write the exempt function for these. With this, we move on to the next slide where we show a demo. So here, this is a Kraken shopping cart example app where there is this locales folder in which we have US, EN, and we have all the properties files which contain the content in a key value format. Here we can see that there are some bad patterns that are present, and the localizability scan plugin will scan these content keys and detect these bad patterns. For example, we can see there is a hard-coded currency code and a hard-coded link in this. We just add the localizability scan as an npm dependency, and we can add a script to run this. Here the script is L10y, and we'll just go ahead and run the script to start the scan. We just do npm run L10y, and it should display all the bad patterns. These are pre-configured as errors or warnings depending on the severity of the violations. For example, you can see here each looks like a sentence fragmentation error, which is the first error detected. Then there are some more detected, like there is a percentage format error. Then there is a hard-coded currency error, and then there is also hard-coded link error where this link has been hard-coded in the content. Now we can look at some of the other properties files and see what patterns have been detected. Here here there are some bad patterns, and in the next file also here there are like some hard-coded countries, states, there's a phone number here, and then we have a hard-coded time zone, we have hard-coded languages. So all these have been detected by this plugin. Now let us also see if we can make some exemptions, and as I said, we can have a config file. The default name is localizability scan.js, and we can just exempt this one key each, which is the first violation that was detected. And let us see if now, since we have enabled this file, let us see if we can exempt this key. After running it again, you see that that first violation is no more the each key, because now we have exempted it. It just performs in a similar way for all other keys. So with this, we come to the end of the demo for localizability scan, and we can move on to the next slide.
Thank you, Ms. Rita. So now let me talk about the continuous integration. Remember that in the past slides, we saw how the developer can use these utilities during the development, right? But it happens a lot of times that even if we provide these utilities, or either they don't pay attention or they skip it, or they forced the code to be, they force the commit to be, So what we wanted to do is that even working with you can do the same thing in your company. You can actually enable it as part of the continuous integration. So this is just definitely a very basic example of a Node application using the Jenkins pipeline. So using Node, everything, you have your own build process right now. Your stage is build, and then you define the steps. So here, the only thing is that you have your regular install. You can have your functional test. You can have your integration test. And the only thing that I'm adding here is that if for some reason you are not doing it right now, but you can actually include the Eslint, having our own plugins, having your own rules. If in the future you do it, you can run the Eslint, and at the same time adding the localizability scan for that one. So as a part of the process, the step, you will run it. Now, each of them, it will probably throw an error, it will throw a warning. So here is some information that can return the Eslint and the localizability, and you can make a decision, right? So right now, for example, if Eslint is throwing an error, it could actually it could break the build, or it will continue with the warnings. But at the same time, you wanna collect all that data and make a decision. What happens if you have like 100 warnings, or you make a decision that, okay, you know what? This is actually this error that is happening is a false positive, right? So you can collect all that information, create it directly in the CI, or you can actually just, here is a basic example that you can have your own dashboard and just make a decision like, oh, this is the error, what is the rule that is actually failing, what is the file, and what is the line. So you can make that decision with the Eslint. Now, if this is a false positive, you can go ahead and modify it. Definitely, the more feedback we get, we can improve those checks of the patterns, right? But if you want to add an exception, you can do it yourself. Don't need to tell us ourselves. Now, from the localizability part, at the same time, you can actually check what is happening. If you have warnings or you have errors, again, the warnings is something that we don't encourage too much of the warnings, but we actually mostly enforce errors. We actually provide errors. So because if we say warnings, nobody's gonna pay attention to that one, right? But for the errors, again, it's like, what is the type of error? If it's an error, a warning, in this case, it's an error. What is the type of rule, the hard-coded date or hard-coded amount, the file where it's happening, and even the key that is happening. So you can actually make the decision, review it. Again, if this is a false positive, you can actually have utility of the exceptions. You can use it, or you can actually just make the decision, hey, this is a bad pattern, please fix it, right? So you can actually, this report that I'm showing here, you can actually send it back to the pull request so the developer can actually see that and make a decision. So we now come back to the at the end of the presentation, which is the conclusion. So as I mentioned at the beginning, we created these utilities and we are using these utilities to catch many of the possible issues that we have seen in the past. We are not just catching anything that we just figured out and say, well, why don't we catch this or we catch? Everything that we're doing is a kind of feedback of past issues. So we do a deep dive in the sense of, oh, this issue, why is happening this issue? And then when we go to the source of truth, is where we ask the question, can we detect this pattern in the future? Yes, so we add it. So if it's in the code side, we use the Eslint. If it's in the content, in the source, we add it in the localizability. We saw a lot of benefit from it. We have been improving a lot of reduced issues in life with using these utilities. And we plan in the future to open source some of those rules, and at the same time, the part of the localizability. So I want to thank you. My peers is Regita and Ritika. Thank you very much for helping putting all this together. And I hope you like it, this presentation. And thank you very much. And please stay safe.